right? Very nice. Thanks. Okay. You got your answers? Why don't you ask your classmate? He seems to know the answers.
Alright, so first way to set a breakpoint. Break.
Is that just like function?
Yeah, so line number or the
Okay, so it's an if statement.
next won't run through the function.
Step
Will run. Will enter the function.
All right.
I don't know what shows the call stack.
Yeah, it's right here. When I say it expression. I'm Zach.
Zach.
H or Zach? One of them is just H.
Okay.
This one goes into the function.
Yeah, one goes into the function and one doesn't.
Yes.
Zero. Should be show the function, right?
No,
it's not.
Your answers. I want to call some people to share with us your answers.
So next goes into the function. And steps skips over the function.
Yeah.
I don't know what shows the call stack. Back. BT. Yeah.
You got your answers?
Which one? I think just show
four?
the
Sorry,
top stack. Just frames.
What's your answer?
BT.
Yes. Can you share your answer with the class?
Yeah.
Okay. Yeah. Why not?
Oh,
Is that okay? What's your name?
Kyle.
Kyle?
Yeah.
All right. Come over. Okay. Kyle is going to share with us his answers.
What?
He says, "That's correct. You can bring your
The
note."
first one put Zach and Ken code.
Now, the class is yours. There you go. Okay. I thought you already wrote it down.
No, I was talking more.
Okay. Then you tell me. I type. Okay. Oh, you want to type?
Yeah, I'll tell you.
Okay.
So, sit next to Andy.
Andy? And who else?
That was all I got to.
All right. You need to work harder. Okay. What functions did they do?
He just did a lot of
Homework.
Yeah.
Is that fun?
No.
No? You need to do some more fun things. Okay.
So break and then the line number.
Break,
Or the file
line
name
number.
and the line number. Or break and then the function name.
Okay. So file, colon, line number, break, function name. Okay? What's the difference between next and the step?
Step will skip over a function, next will enter a function.
Step will execute a function without entering, right? Step will enter the function. Okay? What command will show back code stack?
Backtrace.
Backtrace or BT. Okay, set a conditional breakpoint. Can someone else help? Can you help?
Do you just do B and then you write the conditional equation after that?
And what?
You write the conditional equation.
So you
after
break,
that?
you can say break the function if something. Okay?
Yeah.
What command does F do in GDB? Do you have an answer? Who has an answer?
Shows the top frame and call stack.
Can you say it again?
Shows the top frame and call
Show the top frame of the call stack. Not quite. Can anybody else?
If you add a number after the F, you can say the corresponding frame.
Okay? Alright, thank you. Okay. So if you go to F8, you go to nth frame, the top frame is going to be 0. And the frame 1 means the function calls frame 0. And frame 2 means the function calls frame 1. Got that one?
Yep.
Alright, thank you. Any questions? So I hope everybody knows how to use GDB, right? I will not go through every single command because you have a quick reference. I could go through all the commands. I'm sure everybody falls into sleep very quickly. It's like reading a dictionary. Right? So I'll teach you, I have told you how to read this, and you should take a look and learn many more commands. Any questions? I know today is a cold day. I want to thank you for coming here. I appreciate your participation. You want to share some comments? I thought you said something.
We're just talking about the email we got from President. Tell us we have only one condition, like a day break because of the bad weather in history.
Oh yeah, because of temperature.
Yeah.
I think if it's snow, then that's a different story. Who has seen a video? If you take a boiling water out, it will become snow. Okay, go to find that video. And do you know cold water doesn't work that way? Okay. If you don't know, go to find the video. All right. So last week we talked about call stack, right? We'll continue to talk about call stack a little bit more because that's a foundation understanding how programs work. We talk about call stack. First is stack, means first in, last out. And call stack, we mentioned that every time when a function is called, a new frame is pushed. And this frame will always include the location to return location after the function call. Basically, that's the line number of the function after the function call. So if you have a function call, let's say here you call a function, and let's say this is line x, then the location will be x plus 1, the line after, so you have a location x plus 1 will be in your call stack. Always, there's no exception. And when the function finishes, the top frame, 1 and only 1 is popped. You pop the top frame, 1 and only 1, and there is no exception. Always. So far we talk about calling a function, but a function has many more things, right? And nearly the end of the last lecture, I start talking about arguments. So suppose you have a function, let's say the function has some arguments. Let's say I have an integer a, integer b, character c, then the argument will be put on the call stack as well. So when you call a function, let's say somewhere you call function func, let me put 5, 26, and character b. If you call this function this way, then the call stack will look like the following. You have your location. Suppose this is line x, and your location line x plus 1 will be in your call stack. Then you have a, b, and a c. A will be 5, b will be 26, c will be the character b. Near the end of the last lecture, I mentioned that the symbols actually do not exist in computers. What do I mean by that? If somewhere here you use a, that a refers to this a. If for whatever reason you change the name of a into u, as long as you change everywhere, that function will do exactly the same thing.
Can,
Right.
can you turn off the light?
Turn off the light.
No, maybe a little bit different.
A light in the behind the board.
Yeah.
Is that better?
Yeah.
Is that okay for everybody? All right. Thank you. So which means you can replace the symbol. The symbols have no meaning in computers. What computer has is address and value. Symbols are for human. Computers do not know anything about symbols. This is an important concept because later on when we talk about function call, particularly recursive calls, you have to understand the symbols are all gone before a computer program starts. So let me explain a little bit more what you might mean by address. So you can change it to you. Your program will be exactly the same thing. Any questions so far? So operating system, we usually write OS, will guarantee everything has a unique address. And this address must not be null. This is defined as 0. Operating system guarantees A, B, C, or if you want to replace as U, each one has a unique address. That's guaranteed unless there's a bug in the operating system. And the operating system also guarantees that address must not be 0. So we can write an address since also as a programmer, you have no control of the address. You take whatever operating system gives you. So for our learning, just to make it simple, I usually write 100 here, 101, 102. In reality, the address will be very, very long, but just for writing purpose, I write some numbers there, and as long as it's not 0, they are unique. It's for the purpose of writing. Okay, any questions so far? So this will be a frame. So we have expanded a frame from simply a location. Now a frame also includes the argument. It's the location plus argument. Any questions so far? So if I have a function called another function, suppose I have a function f1 that has an argument a, it does something, and function f2, he also has a, and here is a f1 a plus 9. Then I have another function, that's a main function. I call f2 minus 4. So this will be what the call stack look like. Suppose this is line x, and this is line y. The main function will call f2, so the first thing we'll put, it will be location y plus 1. That's the location after f2 finishes. And then there will be a even though computers do not care about symbols, I still write it because it's easier for us to understand. So I will write 100 here. Then the value will be -4. This will be a frame of F2. Then F2 is going to call function F1. So F1 location is X, so there is a location X plus 1. And then there's A. The A here is going to be this A plus 9, so it will be 5. So this will be 5. And this is going to be the frame of F1. There's a rule, well, there are many rules. There's a rule, a function can see only its frame. Means inside F1, you cannot, the A refers to this A. So you have 100, so this will be 101, this will be 102. When you say A in F1, you mean location 102. So this is a simple address value. When you say A in F1, you mean the A in address 102, and the value currently is 5. Inside F2, when you say A, you mean the A in address 100, and the current value is -4. That's why when you say A plus 9, this A, since this A is the A in F2, you refer to this A -4. I know this is confusing to some of you. As I said before, if you simply replace this by another symbol, the function will do exactly the same thing. That's the reason symbols are not important. What's important is address and value. Every time a function is called, a new frame is pushed. Every time a function finishes, the top frame is popped. Questions? No questions. Great. As you probably know, if you have no questions, I will talk more. If I talk more, there will be more material in the exams, right? That should not surprise you. So, if you don't understand, ask questions. If you don't ask questions, I will talk more. And there will be more to study. So it's your call whether you want to ask questions or not, if you have questions. Okay, so we have said in a frame, there are two things. One is the location. The next is the arguments. Cause that has more, depends on what the function does. If the function has local variables, let's say function integer a, and here I have integer t. This is the local variable. In C program or in any program, you should not have global variables. Even though C allows you to do that, but that's an invitation of disaster. There was a famous paper some years ago, let me find it, called Global Variables Considered Harmful. You should not have global variables. In fact, some newer languages do not allow you to use global variables at all. This is a pretty short paper. It's a very influential paper. Global variables considered harmful. It's only maybe about 2 or 3 pages. It was written in 1973. So if anybody born before 1973? Is anybody born here born before 1973? Okay. So after 1973, this paper was published. If you are born after 1973, you should not use global variables. So if somebody says, you need to use global variables are nice, you say, look, you are 40 years behind the technology because global variables are considered harmful. So let me talk a little bit about human brain, in case you want to ask why. Studies have shown majority of people can only remember 5 to 7 things. Some people are very good, they can remember 11 things. 13 is really on the extreme side. I don't know whether you have experience, you forget things. Do you have experience, you forget things? Probably, right? Majority of people remember 5 to 7 things. The more things you need to remember, the more likely you make mistakes. That's reality. You cannot change that. That's human brain. Global variables make things hard because you need to know where the variables may be changed somewhere else. So that means you need to remember where things may change. The more places you need to remember, the more mistakes you are likely to make. So you don't have a global variables, you don't have to worry about things may change outside your function. You look at the function, whatever you need to know about the function is inside the function. So you don't have to remember anything outside the function. So after this paper, of course there are many more studies since then. Then in the late 70s, people developed something called object-oriented language. Such as C++ or Java. They proposed an idea called encapsulation. Encapsulation simply means try to hide things if you don't need to know. And if you don't need to know, you cannot know. Think about the situation. Let's say you're driving a car. You need to know how to use the steering wheel. You need to know how to add gasoline. You need to know how to accelerate or how to decelerate. Do you need to know how engine works for driving a car? You probably don't need to know how engine works, right? You probably don't need to know how air conditioner works in your car. You just need to know if I turn on the air conditioner, it'll be cooler, right? You don't need to know the details. That's an example of encapsulation. The more things you need to know, the more chance you make mistakes. So you should not use global variables simply because that increases the chance of mistakes. Okay. So if you have a local variables will also be put on the call stack. So if you have a function, let's say I have integer a. Here I have character C. When you call a function, as I give 2C4, so this will be line X. In a call stack will be location X plus 1 of A and the C. This will be symbol. This will be address. This will be value. A value will be 2C4. This value is garbage right now since I have not initialized it yet. And as I said, guaranteed address will be different. This will be a frame. So now a frame is location plus argument plus local variables. So I give you a little bit time to digest. Yes, please.
In the function, suppose I give a value to C after this, and say it's the next line. Then
Okay.
will it change in the frame as well?
So if I say C equal to M,
Yes.
you'll change this to M.
Okay. And likewise, if I change the value of A as well, it will change in the frame, right?
If I change A, very good question. I'm going to address that. Let's say I change to -5. I change to -5. Does that answer your question? Your question?
Yeah, actually.
Go ahead.
Why does it store the local variables? Like, what's the point?
Why does it store local variables
In the frame. Yeah.
in a frame? Because after the function calls, what happens to local variables? They disappear. That's the definition of local variable, right? The local variables exist only inside the function. So where should you store it? The frame. Once the function finishes, so if you say something here and you say C doesn't exist here after the function returns. That's the way C language is designed.
But it doesn't store the execution code of the function in the frame.
The frame, the code stack only stores the data, does not store code. Does that answer your question?
Yes.
Your program is stored somewhere else. Call stack stores only the data. Okay. Another question? Yes?
Suppose my F1 code was A is equal to -5,
Okay.
and then it was character C, and then C is equal to M.
Okay.
Then how would the...
You mean you change the order of these two?
No, I moved the position of character C down. I mean, when you declare character C, I move it down.
You move it down.
Yeah.
Okay.
So, I mean, first I say A is equal to -5.
Okay, let me rewrite it. Okay. So what's your first line?
A is -5.
A is -5.
Yeah. Then
Okay.
character C, and then C is equal to M.
Character C and C equal to M.
Yeah.
Okay. Is that your question?
So then how would the frame work? Would it make a slot for character C and then start the function, or would it set the value of A to -5 and then create a slot for character C?
Okay, so currently now the new C language allows you to do that. The old C language does not allow you to declare C after a statement. The new language allows you to do that, but what happened is the GCC will simply move it up. So even though you think you create character C after A equal to -5, GCC simply move it up, so you will still be followed. You will move up. You don't need to know, but compilers does that. So you will still have C in your frame. Does that answer your question? Okay. Yes, please.
Going back to your first example, if you were doing the location x -1,
X minus 1 or plus 1?
-1 instead.
X minus 1 is here.
Yeah, so
Okay.
wouldn't it be the same though?
Same of what?
Would everything in the call stack be the same? Everything in the frame that you wrote
Well,
down?
if you are X minus 1, you have not called F yet.
Yeah, but I mean, you already set C is equal to M and A is equal to -5. That's all you have written there anyways. So would that be the same?
No, because you have not called function F1, so C doesn't exist. C exists only inside function F1. So if you are before calling F1, suppose you are not calling F1 the line before, therefore, since F1 has not been called, it doesn't exist. C doesn't exist. This frame has not been pushed.
At line X, it doesn't exist either.
C exists only after you call function F1, and that's in line X. If you want to do, if I understand you correctly, you correct me if I don't understand you correctly, okay? You're saying line x minus 1, right? In line minus x minus 1, you have not called function yet.
Right. But
Therefore-
what about line x?
Therefore, these local variables and argument, they don't exist in your call step.
So what about line x?
Line x is a statement.
Also not. It doesn't exist then.
It exists in your code, but you. Let me answer the question a different way, see whether I understand your question. Call stack is a runtime property. Call stack will grow or shrink when your program executes. So if you have not reached, if you don't call F1, the argument doesn't exist, local variable doesn't exist. They exist only when you call function F1. And for F1 finishes, they don't exist either. Does that make sense? Does that answer your question? I'm not sure I understand.
Kind of, yeah.
The frame exists only when you are running the function. So before you call the function, this frame doesn't exist. After finish the function, this frame doesn't exist. Only when you are calling this function, when you are inside F1, this frame exists. That's what I said. When you call a function, a frame is pushed. When the function returns, finishes, the frame is popped. Does that answer your question? Okay. Are you sure? Okay. Another question. Yes, please.
Use the pointer and allocate memory in F1.
Well, that's not worry about pointer yet. Okay, you are very far ahead of me. Okay, let's not worry about pointer yet. Okay, one step at a time. Any more questions? Okay. Now let's consider the situation, the following situation. Suppose you have a function f1, your integer a, and inside, let's say you have integer b. You say a equal to -5, b equal to 7. Your function f2, you also have integer a, you also have integer b. I said before, the symbols do not make difference because you can rename the symbols. And here you say a equal to 2, b equal to -4, and you call f a f1, and here you print a and b. Then you have your main function. You call f2. Let's say a is 6. So you have called f1. Let's say this is line x, and let's say this is line y. As I said before, main function is the starting point of your program, so main will be at the bottom of your call stack. This will be the frame of main. Then you call f2. Since f2 is line y, so this will be line y plus 1. Your local, you can have arguments of a is going to be 6. Why? Because 6 is here. Your local variable b, since I have not initialized yet, b currently is garbage. I change a to 2. This line. I change b to -4, so it's -4. So I'm at this line. I'm going to call function f1 based on the rules. f1, I have a line x plus 1. So this will be the frame of f2. I'm calling f1. f1 has an argument a, and this will be 2 because I copy 2 here. And B currently is garbage. So I'm right before I execute A minus 5. So I change A to A minus 5. I change B to 7. I'm at this line. And function has nothing else to do. So the function ends. When the function ends, the top frame is removed. Now if you want to print A and B, you will print 2 and then minus 4. A function can only see its own frame. It cannot see another frame. Yes, please.
Is print like a function that's in the header file?
No, I should say printf.
I mean, so would that be in the call stack as well? But
Yes.
okay.
When you call function printf, you are calling a function and you will follow the same rules. You're calling printf will also push your stack, I mean a frame, to a call stack. That belongs to the function printf.
But for the sake of this, we're just not showing printf.
Yeah, for the time being, I just want to say, if you print AB, you will print this 2 and minus 4.
Okay.
Now this can be confusing. You say, wait a minute, I changed A and B inside. Why isn't A and B changed? I answer that in 2 different ways. First, a function can see only its frame. That's the first way to answer your question. So when you modify A and B in F1, function F1 has no knowledge about A and B in another frame. That's the first way to answer your question. Why changing AB in F1 does not change AB in F2? That's one way to explain. The second way to explain is you can rename argument and local variable. So if I simply rename this to U, and I rename this to a T, then this will be T, this will be U. From a program's viewpoint, if you rename an argument or rename a variable, local variable, the program, as long as you modify them consistently throughout the function, renaming them has no effect. Therefore, you simply rename it. And I said several times, programs do not care about symbols. Programs care about address and values. You rename it to U, now it doesn't call it, it's not called A anymore. And that may also explain why changing U or changing T has no effect on AB in frame 2. Yes?
What if you put return B in function?
We'll talk about return in a moment. Okay.
So if function 1 is inside function, does it consider part of the frame of 2? No.
Function F1 is,
Inside the function.
what do you mean by inside?
You call F1 inside F2.
Okay, I call F1 inside F2.
Isn't it a part of the frame of F2?
No, the frame is not part of F2. It's going to have its own frame. Every time you call a function, a new frame will be pushed. And that frame is not part of F2. It has its own frame. Yes, please.
So when you call F1, you say that A starts at 2 and B starts at nothing? B starts at nothing.
Yes, correct.
2 becomes -5.
2 becomes -5, yes.
And nothing, garbage becomes 7.
Well, I changed to 7 now.
But what was it before 7?
Before 7 is garbage.
But why isn't it before 7 -4?
Say that again, I'm sorry.
Shouldn't B be -4 and then you change -4 to 7?
No, because B is local. This T has nothing to do with this B. Remember, I renamed it to T. It has nothing to do with this B. So T is not initialized. T original is garbage. Does that answer your question? one thing you have to change if that still confuse you. Remember, computers do not care about symbols. So this B has nothing to do with that B in a different frame. That A has nothing to do with that A in a different frame.
Okay, so when you call F2,
When you call F2,
yeah, does B start as garbage? And then
does B start with garbage? Yes. I put dash there, then I change to -4. Yes.
Oh,
I saw another hand there.
Yeah.
Yes, go ahead.
If you called F1 in main
I pack off F1 in main, okay?
instead of in F2, does that have a different effect?
Yes.
on output?
So let's say I call F1. Let's say my main function is different. Let me see whether I understand you. Main function. I call F1. Let's say give what? 0, okay? Let's say this is line Z. Then based on the rule, I will have a location Z plus 1. And it's 0, so I have U is 0. And the T is garbage. Does that answer your question? And this will be the frame of a main. This will be the frame of F1. Does that answer your question? Okay, any other question? Yes, please.
Refreshment. Just why did you cancel out the top frame?
Which top frame?
You slice there. Yeah. Why did you cancel out?
Oh, because I say after F1 finishes, I want to print AB. When I print AB, F1 is already done.
Okay.
Right?
Yeah.
You cannot print AB when you are still in F1. Does that make sense?
Oh yeah.
You can print AB only F1 finishes. When F1 finishes, the top frame is gone.
Okay.
Yes, I think, did you raise your hand? Okay. Any more questions? Yes, please.
So if you want to get the value of F1 in the U and T back out to F2, what would you do?
You want to get U and T out?
Back to F2.
Get back to F2. There are two ways. One is return, one is pointer. We'll deal with that in a moment. Okay. Now I'll talk about the return in a moment. So now we have three things in our call stack. The return location, the line number after the function call, we have argument, we have local variables. Okay? The return location is always there. Your function may not have an argument. It's very unclear why you would write a function without argument, but you can. If your function has no argument, of course there's no argument in the call stack. If your function has no local variable, there's no local variable in the call stack. You probably should not write a function without argument. And you probably should not write a function without local variable, probably. So in that case, you have three things. Okay? So now, let me now talk about return. Suppose you have a return. I use integer as an example. We'll talk about other types in a moment. Let's say I have integer A, integer B, so this is probably a function you'll look familiar to you, right? You probably write some functions like this with return. And you want to call this function. Let's say I have an event function. I'm going to use T. First, you can call a function. Even though a function returns something, you can say, I don't want it. I can say 5 and 7. Even though a function returns, you throw it away. That's legal. It's not clear why you want to do that, but it's okay. It's legal. More likely, what you'll do is you'll write T here. You'll assign a returned variable into something. So we'll follow the same rule. Suppose this line x. Now I need to talk about main, the frame for main. Remember I said the button is going to be the frame of a main function. T is a local variable, so T will be here in the frame of a main function. Everything has its address, so I'm going to give address 100. Current is garbage because I have not initialized T yet. I'm going to call a function. I said the function call, they will have a frame. The frame will have 3 things. Now I'm going to add the 4th thing. I have a location. It's going to be x plus y. I will have another thing, it's called address. And it's going to be 100. Why? Because I said the returned value is going to be returned to address 100. We start with only one thing in the call stack, right? The location after the function call. That's the very first thing. Then we add argument. Then we add local variables. Now we add the address the function returns variable b. Fortunately, there are only 4 things in your call stack, so we are done. There are only 4 things in the call stack, and I have covered all 4 of them. So first is the location after the call. The second is the argument or arguments. The third will be local variables. And the fourth is the address to store the returned variable. In this case, we want to write the returned variable to t, so 100 will be stored here. If the address of t is different, let's say it's 509, this will be 509. Why is that this case? Because I write t equals something. So GCC says, okay, you want to modify t, I'm going to put the address of t in your call stack. It's done by GCC. Yes, please.
What if we don't write t equal to this thing, and what is the address location then?
Address location of what?
In the second string.
This one or that one?
Yeah.
Location?
Yeah.
Location means the line after the function call.
So this will be
It will be x plus 1. Suppose this is line x. Address will be the address of t. Does that answer your question?
Yeah.
Okay, yes, please.
In the call stack, is 509 considered an address or a value?
It will be the address.
Okay.
It's not a variable. Because 509 is address. The variable currently is garbage. Right? Because I have not initialized the variable yet.
Yeah, well, I mean, like in the frame of F,
Okay?
yeah, is the 509 right there? Is that a value or?
Here it's not a, this will be a special symbol marked by GCC.
Okay,
Says it's 509.
all right.
You don't see it in your program.
Yeah.
GCC does that for you.
Okay.
In your program, you don't see x plus 1, you don't see 509.
All right.
You see A, B, and C in your program. Does that answer your question?
Yeah.
So you can see GCC does a lot of work for you. It's a friend of F. Okay, so then I will put argument A, B, and then local variable C. So A will be 5, because I call A with 5. B will be 7, because the second argument is 7. C, start with garbage. But then I say C equal to A plus B, so C becomes 12. Then I said return C. So I'm going to write 12 somewhere. Where should I write it? I look at the address, and the address is 509, so I change it to 12. So T becomes 12 now. Let me finish, okay? T becomes 12. Since there's nothing else after this function, this frame is gone. T becomes 12. Yes?
So does C not have its own address, or is it?
C has its own address, A has address, B has address, C has address.
So its address just also copies it to 509 too?
No, they have their own address. So let's say this will be 524, this may be 529, this may be 531. They have their own address. Everything has its own address, and the address are guaranteed to be different, and must not be 0. It's guaranteed by the system. Yes?
Does T change its value before or after F is popped off the stack?
It doesn't really matter for you, because when it's all handled by GCC.
All right.
So another question I frequently get, what's the order between them? Should A be above B or F below C, or should address be above A? You don't really care, because that's handled by GCC, and it's possible to be different for different processors. And for our purpose is for you to understand how this works. You don't need to worry which one should be above or below. When you take a course on compiler, then you need to worry about should A be above or below, or should the address be above or below. In this course, 234, since it's all hidden from you, it's all handled by GCC, so you don't have to worry about who is going to be above or below. As long as you know, the call stack will have 4 things. Okay, I'll give you a little bit time to digest. Any questions? Yes, please.
So here in code we say integer main, we've done 0, right? So then how would the frame of main look there?
Okay, we'll talk about main function more later. Let's take one step each time. Okay, you're always ahead of me. So do I answer your question about return?
Yes.
Okay. Any more questions? Any questions going once? Yes, please.
On the first function, if you said return 0, not just say, would you change the value of say to 12?
Return where?
Say equals to A plus B and then return 0.
Return 0.
Yes, so would you change the top frame, I mean the value of say in the top frame?
Return 0, where would 0 be written to? T, so I would here to become 0.
Yes, but my question is the C values.
C will be 12. But
Still
then when you
12.
return, that frame is gone. C doesn't exist anymore.
So it's still garbage?
This frame is gone.
Oh,
So C is still 12, but then this whole frame is gone, so it doesn't exist anymore. It doesn't matter if it's 12 or not.
but
That frame disappears.
but return is inside the function.
Yes. You return 0. 0 will be returned to address 509, so T becomes 0.
Let me address this question.
Please.
You return 12 to C because
I
of
didn't return 12 to C. I returned C.
I mean, you put the value of 12 to C because the command of C equals to A plus B, or just to return C? Which
I say C equal to A plus B, so C becomes 12.
So it's nothing to do with the return to C.
It has nothing to do with the return,
Okay.
right?
Yes.
Then the return depends on what you return here. If you return 0, where will you write 0? Based on the address, you'll write to 509. So T becomes 0.
Answer my question.
And since after return, the frame is popped, it doesn't matter what the value C is. C doesn't exist anymore.
Okay.
So another thing you need to know is after a function return, the function terminate or stop, depending on whatever you want to call it. What it means is if a function, here we say return something, then anything after return is not meaningful. The function will not continue. Actually, I even put semicolon there. You actually will get the GCC warning saying you have something after return, but they are completely meaningless. You'll never get there. You'll never execute the code here because of the return. Yes?
So that's not executed, like if we have a pointer down there, it won't execute both.
The code after return will not execute. You can, of course, you can say if something return, then that will only stop if condition is true. If condition is false, obviously you will continue here, right? Does that answer your question? Okay, any other questions? I know I have told you a lot of stuff today. So again, any more questions? Yes, please.
When the top frame is popped,
Yes.
do the addresses that the frame uses become available again when it's
The address here, yes, become available. But remember I said you don't control the address. You don't care. Does that answer your question? Think about it. Whenever I say you don't care, it would not be nice. You don't have to worry about it. Right? So, is that good?
Yeah.
You don't care. You don't have to worry about it. Any more questions? Please. Okay. Going once? Any more questions? Going twice? Alright, take out a piece of paper. Let's do a practice. Okay, I'm going to type it since I think that will do the really nicely. So please draw a call stack. You're more than welcome to discuss with your neighbor. Yes, please.
I think you want to change the F2 in the function F2 to F1.
Yeah, that's right. Thank you. Okay. Thank you for the correction. Oh yeah. Very good. People are paying attention. I need to just a little bit higher. Okay. You're welcome to discuss with your neighbors. The only thing you cannot discuss with neighbors is during the exam. Done? Well, sure. You want that number? I give you that number. How about this is, I just use the 9 number here. Okay, 971. This will be 22. How's that? Is that good? Okay. How are we doing here? Okay, some more time. How are we doing here? Good. Okay. Again, you are welcome to exchange your answers with your neighbor. This is pretty well. Moving forward. Good. How are you doing here? You okay? All right, very good. Moving forward, good. Any questions? Almost done? Okay, still working on it? You may want to get a bigger notebook. Almost done? Close? Alright. Doing okay? You done? You're missing things, you know? You're missing things. Don't try to take shortcut. I've seen many students, they try to take shortcut. They skip one line here and there and then make mistakes. So remember the 4 things. So for your reference, I'm going to put that piece of paper here. Maybe I should write it down again. So there are 4 things in your call stack. One is the location, F the call. Second is your argument or arguments. Third, local variable. Fourth is the address for return variable. These are 4 things. Raise your hand if you need more time. All right, I will give you more time. You done? Can you talk to the class? All right, come over. Let's see what you agree with him. I will put it side by side. And all right, it's yours. It's up to you. You want to show us, or you want to? All right. Okay. So can you explain?
Yeah. So this is the main frame. So if I have X, I give it an address of 100. It has garbage. Then we call F2. So I created F2 frame. It has a line 84. It points to address 100 because it returns to X. We have a variable U and T. I've given them 102 and 104 as address. We're passing 2 and my -5 to that. So I've sent that. Then the function calls F1. So F1 will point to line 78. It'll have an address 104 because it points to T. There'll be variables A, B, and then C. I've given them all addresses 106, 108, 110. A gets 4 and B gets 9 because it's 2 plus 2, 4, and -5, -4, -9. C is A plus B, so that's -5. We return C to T, so -5 goes to address 104. So this value gets -5 over here after we close F1. So we have -5 and 2 in U and T. It returns to address 100, which is X, so X gets -5.
Do you agree, team? Anybody else? All right, thank you. All right. Now I know some of you may think it's tedious, but you have to do it a few times to reach the point you are very comfortable. Yes?
Do we know the address of the variable, or we just assume?
The address of variable, you just give something unique. Okay? Yes?
So does the line number have an address?
That's what?
Does the line number have an address?
Line number in address? No, there's no line number in address.
Okay.
Line number corresponds to the source code, right?
I mean, like, does the line number have an address? That's the question.
They will have address. Okay, so I try to make it simple, but you want to make it okay. All right. All right. Since you asked, I try to be lazy. Okay. So there's a location. Location has its own address. When I say x plus 1, line 78 or something, it has its own address. And the address has its own address as well. So let's say you have an address here, 509. You store 509, but it has its own address as well. Sorry, I try to be lazy, but you don't allow me to be lazy. Does that answer your question?
Yeah.
Okay. All right. Any more questions? So, do you think you understand call stack now? Are you sure? Really sure? Absolutely sure? Going once? Twice? 3? All right. Let's do another practice. Now you may say, why are we doing so many practices? Because without understanding call stack, it will be very difficult to understand pointers, memory allocation, recursion, pretty much anything else if you don't understand call stack. All right. You really sure you understand? Very good. Let's try something new. Okay. As you can see, this is a recursive function. Recursive function follows exactly the same rule of call stack. As I said several times, the good thing about call stack is the rules have no exception. You always follow the same rules. That makes it very nice. Let me do it, maybe this jump too fast. Let me make it a little bit, break it into 2 steps. That may be a little bit easier.
Are we still returning A or we return B?
Return B, thank you. Okay, I will rewrite this. Okay, don't panic. I will rewrite it in the same way to make it simpler, so I don't have to declare here. Because actually the compiler will move the declaration up anyway. Okay. Yes, please.
You said that the compiler moved the declaration up, right?
Yes.
So then, if we had not set int A and int B at the top like right now, then would A and B have would they have got their values before the function started?
There will be garbage.
No, in the previous function you have written.
That, well, you don't use that anyway. Here, compiler will move the declaration up. Since you never used them earlier, you don't care, it's garbage. Right? Does that answer your question? See, there are many things you don't have to worry about. That makes life easier. Raise your hand if you need more time. All right, I give you 1 more minute. In case you want to give line number, that makes it more precise. I should change. Sorry about that. Okay, do you want to see the answer? Or you prefer to do it next week? I mean, next class?
Next class.
Excuse me?
Show now.
Show now, okay. All right. So, I'm going to put side by side. So I have t equal to -4. I first put the location t here, and the address is 100. Location is 129, the line after. And then address, since I changed t, so address will be 100. This because t equals something, so I have to say address there. Then I call the function. So function has argument n. I'm going to write 101, 102, 103. Nth value is 2. Because I say t equal to f2. Then I have local variable a and b. Currently it's garbage. And I say if n equal to 0, n currently is 2, so it's not 0. Therefore, the if statement is not true. Then I will say a equal to f n minus 1. I'm in this line right now. A equal to, I'm at this line right now because the if statement is not true. A equal to f n minus 1. That means I'm going to call a function. I'll call a function, so I have location. This location will be line 121, the line after the function call. And I have address. This address is the address of A. Yes. Address of A is going to be 104. Because I say A equals to something. Here address is 100 because I say t equals something. Then I have argument n. N is this n minus 1, so it becomes 1. I have local variable a and b. Currently it's garbage. This is a frame. This is one frame. Frames, the boundary of frame will be the locations. So that's the reason I write down location. You use location to separate the frame. And let's say this is the address 106, 107, 108, 109, 110. I look at n. N is not 0, so the if statement is not true. Therefore, I call the function again. So this will be another frame. And this will be location. Location is going to be line 121. Since I say A equal to something, so this A will be address 109. That's this one. And this n will be 0 because I have 1 minus 1. It's going to be 0. I also have local variable a and b. Since n is 0, you will return 0. That's what the if statement does. Return 0. Based on the address, I'm going to write to 0 here. Because 109, I'm going to write 0 here. So this frame is popped. Then b is a plus n. A is 0, n is 1, so b becomes 1. And then, based on the location, I go back to line 121, and I will return b. b is 1, return to location 104. So I will write 1 here, because location 104. Yes?
Why doesn't do a equal to f negative 1?
I already did, 0.
Yeah, I mean,
Because n is 0, so you return 0, so 109, right to here.
yeah, but after that, you will do a equals to something again, right?
Yes, so I will return b. The function will return b, right? b is 1, so where will it write to? We'll write to address 104. Let me finish. I will talk again on Thursday. Okay. So treat this as a preview. Okay. So then I return 1. So this frame is popped. After the function returns, the function has nothing to do, and that frame is popped. So I have a. B is going to be a plus n. N is 2, so b becomes 3. The function will return 3. Where will you write 3 to? You write 3 to address 100, so this becomes 3. And this frame is popped. Therefore, after you execute this recursive function, t will become 3. We run out of time. We'll continue on Thursday. All right?
Is it A and B a garbage on top frame?
They are popped anyway. They disappear.
Okay.
Your question? No, because
是吗？周五是春节啊。
国内一个30，咱们那儿的大概4个中午。如果你要用这个看一下你一个 course， 你怎么学到的？他上次不是。